Imagine the entire universe squeezed into a tiny point, smaller than a grain of sand. That's what scientists think happened around 13.8 billion years ago. Suddenly, this tiny point exploded with unimaginable force. We call this the Big Bang, the grand event that marked the beginning of space and time as we know it. From that moment, the universe started expanding and cooling, eventually forming the stars, galaxies, and planets we see today. Pretty mind-blowing, right? But how do we know this incredible story? Well, scientists have gathered a lot of evidence to support the Big Bang theory. They observed that galaxies are moving away from each other, like dots on an expanding balloon. They've also detected faint radiation left over from the Big Bang, like a cosmic afterglow. This radiation, called the cosmic microwave background, gives us a glimpse of the universe just a few 100,000 years after the Big Bang. Think about it. We can actually study the ancient light from the early universe. It's like looking back in time to witness the birth of everything around us. The Big Bang theory is one of the most successful scientific theories ever, explaining a vast amount of what we observe in the cosmos. Now let's talk about how we know the universe is expanding. Enter Edwin Hubble, a famous astronomer who made a groundbreaking discovery in the 1920s. Hubble observed that galaxies are moving away from us, and the farther away a galaxy is, the faster it's moving. This relationship between distance and speed is known as Hubble's law. Imagine you're baking a loaf of raisin bread. As the dough rises, the raisins move farther apart from each other. Similarly, as the universe expands, the galaxies within it move apart. Hubble's law is like measuring the speed of those raisins as the bread rises, giving us direct evidence of the universe's expansion. Hubble's discovery revolutionized our understanding of the universe. Before his observations, most astronomers thought the universe was static and unchanging, but Hubble showed us that the universe is dynamic, constantly evolving and growing larger. His work laid the foundation for modern cosmology, the study of the universe's origin and evolution. Here's where things get even more interesting. Scientists studying the expansion of the universe in the late 1990s made a startling discovery. The expansion is accelerating. It's like hitting the gas pedal on an already moving car. This unexpected finding suggests that there's an unknown force at play, pushing everything apart at an ever-increasing rate. We call this mysterious force dark energy. Think of dark energy like an invisible hand stretching the fabric of space-time, causing the universe to expand faster and faster. We don't know what dark energy is exactly, but it's estimated to make up around 70% of the total energy density of the universe. Remember the cosmic microwave background, CMB, we talked about earlier, that faint afterglow of the Big Bang? Well, it turns out the CMB holds a wealth of information about the early universe. By studying the tiny temperature fluctuations in the CMB, scientists can learn about the conditions present just moments after the Big Bang. It's like looking for clues in a fossil to understand the creature that left it behind. The CMB tells us that the early universe was incredibly hot and dense, and it provides evidence for a period of rapid expansion called inflation, which happened in the first fraction of a second after the Big Bang. Inflation theory helps explain some of the observed properties of the universe, like its large-scale structure and uniformity. Studying the CMB is like listening to the faint whispers of the early universe, revealing its secrets and helping us piece together the story of its evolution.